11.7 is about areas and volumes of similar solids. We've already talked about areas being a squared to b squared, right there. Just like a to b is your scale factor, area is a squared to b squared. The ratio of volumes is a cubed to b cubed. And we're doing the same thing we did earlier. Okay, if we look at problem 1, are the two rectangle prisms similar? If so, what is the scale factor of the first figure to the second figure? So if we're looking at A, you want to do each side and make sure it all equals each other. So 3 over 6, does that equal 3 over 6? Of course, it's 1/2. And does that equal 2 over 4? Of course, those all would reduce to 1/2. I'm sorry, 1/2, 1/2, and 1/2. So those are equal, those are similar. But if we look over here at the second one, we look at the sides, that's 2/3. You look at the other side, which kind of matches that to that, is 2/3. But if you look at this last side, 3 over 6, which would reduce to 1/2, is not equal. So these are not similar. In problem 2, they tell me the square prisms at the right are similar. What is the scale factor of the smaller prism to the larger prism? So again, they want smaller to larger. This is where we struggle a little bit reading instructions. So smaller to larger, well, this one's the smaller, this one's the larger. So if we go 729 over 1331. If you want larger to smaller, you would go the opposite. But that's going to equal a cubed over b cubed. And just like areas, the opposite of squaring something is square rooting. The opposite of cubing something would be to cube root it. So I want to cube root a cubed and cube root b cubed. That would give me a over b. I'm going to do the same thing over here. Cube root 729 and cube root 1331. That's what's going to end up giving me 9 over 11. That's my scale factor. Or and you can always represent it with that way as well. Problem 3 talks about using the scale factor. They give me the lateral areas of two similar paint cans are 1,019 centimeters squared and 425 centimeters squared. The volume of the smaller can is 1,157 centimeters cubed. What is the volume of the larger can? So again, you got to use the two areas to find the scale factor first. It doesn't really matter how you put them, but I'm going to go 1019 over 425, and that's going to give me a squared over b squared. Why? Because it's talking about areas. Remember, the scale factor or the ratio of areas is a squared over b squared. How do I solve? Square root. So I end up with a over b equals the square root of 1019 over the square root of 425. Now, the square root of 1019 and the square root of 425 are ugly answers. And we always talked about you never, ever, ever, ever round in the middle of a problem. That's what Miss Ballard says, the one thing she's learned from me all year. But we don't want to round this. So if that's my scale factor, just use it. So the square root of 1019 over 425 square root equals, and they give me the volume of the smaller can. Well, square root of 425 is smaller, so that's going to be 1157. We want to know the volume of the larger can, x. Okay, now we know in order to do this, I've got to go ahead and cube it because we're talking about scale factors and volume. So we're going to cube that over here, and that's what you do. So it's going to be to solve for larger. So let's just multiply both sides by 1157 here. Make sure you multiply this side also by 1157. That should be a 7. Okay. So let me make that better. Now, again, punch this in my calculator first. Hit the cube root of 1019 divided by the cube root of 425. Hit enter. Okay, and then once you have that number, just don't hit anything. Just hit times 1157, and that will give you your answer. And then you round. End of the problem, you round, and you should get around 4,295 centimeters cubed. Obviously, it's a big decimal, but we're going to round to the nearest whole number.